In 1947, a fruit fly traveled in space on a V-2 rocket launched by the United States. It's the first creature to go to space and come back alive. After that, all kinds of Earth products were sent into space. Next, humans will send trains up there. I'm kidding, this won't happen. In fact, it's vegetables that scientists have been working on to bring to space to study. Early in 1975, the Soviet Union began exploration of space plant cultivation. They tried to grow wheat, onions, etc. in the spacecraft. 40 years later, the main food for astronauts in space is still freeze-dried and canned food, which is far from tasty. China develops rapidly in this area, and the Chinese astronauts who went to the space station on Shenzhou 13 all enjoy dumplings in this Chinese New Year. Growing vegetables in space is about much more than that. Firstly, let's talk about how difficult it is to grow vegetables in space. Plants need air, sunlight, temperature, water, and nutrients to grow. It takes a lot of effort to stimulate this in a small spaceship silo. The veggie system realizes it. The vegetable production system is a deployable plant growth system developed and used by NASA in outer space that includes plant pillows, LED lights, fans, bellows, mobile space, and a base. It's a vegetable greenhouse that can be taken to space. There are red, green, and blue LED lights on top of the machine. Red and blue are for plant growth, while green light is to make the combination light look like common light. In addition to light, planting requires soil. A soil veggie is in the storage layer that can hold up to 6 plants. Each plant grows in a pillow filled with media and fertilizer, and circulating water flows along capillary-like pipes to the pillow to feed the plant roots. Meanwhile, a bellow shell made of fluorinated polymer is connected to a lighting system at the top and a storage layer at the bottom. Its height can be adjusted according to different growth stages of plants to help plants better photosynthesize and repair. However, there is one important factor missing: gravity. Lives on the Earth have evolved under one gravity unit. Seeds, no matter how they're planted, germinated with roots down and stems up. Without gravity in space, the direction of radical growth can be only controlled by the direction of the seeds. Therefore, when growing vegetables in space, the seeds are fixed in a substrate with bioglue, with radical down and germ up. Even if the plants germinate successfully, with microgravity, their roots are uncontrolled. Their leaves and stems are more free to play. Bedding structure and swing greatly affect nutrient transport and photosynthesis, resulting in crop failure. From a micro perspective, in the case of the amyloplast of core root cells, starch is its mainstay, and microgravity causes less starch and more oil droplets. It's obvious that microgravity has an impact on the reproduction, growth, and development of plants. Despite the difficulties, the veggie system has successfully grown lettuce, zinnia, Chinese cabbage, Mizuno mustard, etc. Assuming we overcame the above difficulties, there's another more terrible killer who's invisible: radiation. From March 2015 to March 2016, astronaut Scott Kelly spent a year on the International Space Station while his twin brother, Mark Kelly, lived on Earth. By contrast, the telomeres and the outer Scott's chromosomes were found to have changed 1 year later. Besides, his chromosomes showed abnormalities such as inversions and translocations. Scientists believe that they are likely to be affected by space radiation. Plants are more resistant to high radiation than mammals because of differences in cell type and metabolic structure, but the effect shouldn't be underestimated. The radiation breaks through the cell and damages DNA and chromosomes. If this damage was beyond the DNA repair capacity, it causes genetic mutations and cell death. Growing vegetables in space is difficult, and there are many potential dangers. Then why do we continue to do so? Future space missions may involve 46 astronauts who live in a very small space. Sooner or later, humans will establish colonies on the Moon and Mars. Therefore, fresh food is needed as preparation for long-term space travel. A journey to Mars will take nearly 8 months each way, plus a stay on Mars that could take a year and a half. The vitamins of freeze-dried and prepackaged food will break down over time and can meet human nutritional needs. In the age of exploration, many sailors suffer scurvy due to lack of vitamin C for the lack of fresh vegetables and fruits. It's the same for space travel. Growing vegetables could be the main means for astronauts to get fresh food. Future aerospace technology may make it possible for space plants to absorb carbon dioxide exhaled by humans to produce oxygen needed at human feces to produce fresh vegetables and fruits. The current level of human spaceflight doesn't allow for self-sufficiency yet. There are 390,000 known plant species, but currently only 20 or so are being successfully grown in space. So if humans want to travel to space, colonize the solar system, perhaps the most urgent technology is to grow vegetables. Thank you for watching. Please hit the like and subscribe button if you enjoy it.